Hello class, welcome to investigation 2.3 for coverings and surroundings. Last section we covered was 2.1 and that dealt with fixed area, where the area stayed the same and the perimeter changed. Where this is going to be a little bit of a different scenario for this unique shape. It's a fixed perimeter. The perimeter will stay the same this time, and then the area will change. So I just ask that you yourself read these goals and then we will move on. So I'm going to ask you to pause it and I'll wait 5 seconds for you to do that. Alright, so I'm hoping that you paused it and read your goals and then so you kind of can know where we're going with this. So, alright. We are dealing with fixed perimeter and with a varying area, as you very well have seen. I have a couple figures here that we're going to walk through in a minute, but I just want to kind of go back and show you an example of what or how to find the dimensions of a fixed perimeter. Now, first of all, what do you notice about the left and the right side of this rectangle? What do you notice about them? They're exactly the same. They are exactly the same. Left is a 2, right is a 2. Okay. What do you notice about the top and the bottom? Yes, they are also exactly the same. So the top and the bottom are exactly the same as well. They're both 10. Now, so in order for you to find the perimeter, what you normally would do is you would, of course, add them up, so 2 plus 10 plus 2 plus 10. Alright, so that would equal 24. Alright. Perfect. Alright, now what do you notice about this? You have, I'd say, 2 sets of adding. So would it make sense if I just did this? If I did 2 plus 10. You got those and you got 12. Okay. And then you just multiply the 12 by 2. Do you think we can do that? Get the same answer? Yeah, of course we can. So I'm going to kind of reverse engineer this to do exactly the same thing but backwards. So if we started out with 24 perimeter, we don't know this part, so let's erase this. Sorry. If we don't know this right now, we can figure out dimensions for them. Alright, so here you are. Let's get rid of these. Okay, so we know that the area is 24, the perimeter is 24. Okay, so what I would do in order to solve for this is I would say, okay, 24 is the perimeter. Then I would divide it by 2 to get and find this number here. Okay, I would find and divide it by 2. Why would I divide it by 2? Well, if you divide it by 2, you'll get 2 of the sides. Exactly 2 of the sides. If you divide it by 2, you get 12. 12 is, if you remember, it's this side plus this side. It's 2 sides. Now, all I need to do is figure out factors or numbers that would go into or add up to 12. Okay, so if I wanted to do this, I could do 1 plus 11. That is those go into 12. I can do that, so I'm just going to do 1 and 11. All right, is this perimeter 12, 24? Well, let's find out. 1 plus 1 plus 11 plus 11. Yeah, it definitely is. Definitely works. So I'm just going to go through these so you see that and hopefully you understand what we did. Let's figure this out. So we have now a different scenario. Obviously, is our perimeter is 12. Okay, so our perimeter is 12. Let's do another example. Kind of what we did before is I would take the 12. Alright, so 12 and divide it by 2. Alright, so divide by 2. That would give us 6. Okay, so this 6 represents 2 of the sides. Alright, and it represents either this side and this side, or it represents 2 of the sides. This side and this side, let's choose. Okay, so things that add up to 6. I mean, starting off with 1 is a good choice. So 1 plus 5 would be your 2 sides. Okay. Now, question: does this add up to 12? Well, let's find out. 1 plus 5 plus 1 plus 5. That's 10. That's 12. Yep, the perimeter is 12. Okay. Sweet. All right, let's do a different one. I'm just going to do the next number. So we started off with 1. Let's do 2. So 2 plus what? 2 plus 4. That works. 2 plus 4 is 6. 6 plus 2 is 8. 8 plus 4 is 12. That works also. Let's do it again. All right, so let's do 3 next time. Okay. 3 plus what is it going to equal to? 6. Well, 3 plus 3. Look at that. Perfect square. 3 plus 3 plus 3 plus 3 is going to equal to 12. Alright, I'm going to do the next number, 4. See what I'm doing? I'm just going up in numerical order. 1 plus 1 and 2 and 3 and 4. That's all I'm doing. And then I'm just trying to find this other number. So 4 plus 2 equals that. And it's going to also equal to 12 if you find that out. Alright, next is going to be S2 5. And I'd say it's 1. Okay. Now here's a quick question. Why did I stop at 5? Well, if it went up to 6, say if I had a rectangle with 6, let's just pop that right here. It's not going to be to scale, so I just wanted to kind of show you what's going on here. So what if I did this to 6? 6 plus what would have to equal to 6? I mean, it would be technically 0. Is there such thing as a 6 times 0 for what would that mean? It's not really a rectangle, so you have to do a number. 2 numbers have to equal up to the half of the perimeter, which is 6. So, because we did that, we're able to figure this out. Okay. All right. I'm just going to eliminate that. All right. What I want you to do is to record this on the table here. So we already have the length of the first one. It's a 1, and I believe it's 5. All right. 1 plus 5 is I'm sorry. The perimeter is going to be 12. And then the area is going to be 5 times 1 is 5. Alright. Now what I want you to do is, again, to do this before class so that we can kind of have this as your experience. But notice this. Perimeter stays the same. It's a fixed perimeter. So that stays the same, and that's going to be consistent all the way through. Okay. And there's 6 units. So when you write the labels, make sure you put units. It's just as important. Okay. Alright, well, thanks for watching.